Hello and welcome to Waterproofing Wisdom. My name is Ben. I am the Technical Director of CLW, and in this episode I wanted to talk about waterproofing the ground floor, which seems like an odd thing to say. But if I show you this section detail, this I think is becoming much more common in, I guess, residential buildings in the UK. And the red line here is intended to indicate a damp-proof membrane under insulation and a screed, and this red line is intended to be a cavity tray. And in some ways, nothing unusual about that, and you get that sort of detail with a door in it as a level threshold, which is standard practice, particularly with disabled access requirements. But if I then remove the white patch and you see the section through the whole building, what you can see is that the whole building is actually below ground level, only very slightly, but it is. And a damp-proof membrane is exactly that. It's a damp-proof membrane and not a waterproofing membrane. This is how most buildings used to be built, I think, and you would anticipate a step up into the building. And increasingly common, I think, is for the building to be set down so that finished floor level is roughly the same as external ground level. And I think that causes issues. And I wanted to show you an example. This is from a job that I worked on a long time ago, but these are the details here, and I've added in red just to accentuate. Here's the damp-proof membrane under the floor slab, and up, there's the cavity tray. External ground level here, finished floor level here. In some ways, not a big deal, but that was actually the full perimeter of the building. It was always like that, the whole way around the building. And the problem with that, I think, in this situation was a very, very high ground level, water table, very high water table, very poorly drained soil. And so that I've put this blue shading there to indicate the presence of water. And with the presence of water there, and if we assume that the damp-proof membrane is actually keeping water out, then you would expect some sort of hydrostatic force to be acting on the damp-proof membrane, and water's trying to get in. There's potential for flotation forces as well. That's the scenario. If we look at the same project during construction, you can see in the back here that there is there's puddles. It's poorly drained soil. Actually, the puddles are slightly more obvious back here, but poorly drained soil and external ground level, the same as internal finished floor level throughout. That led to this, where there was a lot of moisture under the vinyl. The adhesive got wet and didn't like that situation. Very high moisture content in the floor. And you can see here the internal floor level was very similar to external ground level. And so because of that, I wonder if even some ground floor structures need waterproofing design advice, where the water table or where external ground level is the same as internal finished floor level, because that is essentially earth retaining. And even if that design advice is simply to assess the risk and say no further action needed, architect can carry on and design with a DPM as they normally would, then so be it. But assessing the hydrogeology and flood risk, all of that content, that should be something that a waterproofing designer could bring to the party, and that could actually be a very helpful requirement. So I think even ground floors can require structural waterproofing, and I think that the people who should be assessing that risk and designing, if necessary, is structural waterproofing designer. And I think within that, like I mentioned, you'd want to be thinking through flood risk and the risk of surface water flooding or other forms of flooding, and considering the hydrogeology. So thank you for watching. This is Waterproofing Wisdom. If you've got any queries about basements or waterproofing or even ground floor waterproofing, give me a call. Thank you.